this is a problem that uses Newton's method. So we are trying to use Newton's method to find all root of this equation correct to 6 decimal places. So this equation here is phi cosine x equal to x plus 1. There are 2 steps to solve this problem. The first step here, you will draw the graph and see how many intersection points that you have. So how many solutions do you have here? Because the root of this equation over here correspond to, if you graph this, y equal to phi cosine x, which is this left side over here. And if you graph y equal to x plus 1, okay, that's this right side over here. And when they're equal, and that's where they intersect each other. And you see that there are 3 intersection point. Okay, intersecting point. So we should expect there are 3 solutions. And further, by looking at the graph, this graph here, you can use decimal. Okay, so a lot of you already use that. By looking at the graph over here, you see that this, the x coordinate is kind of near this -4. And then this one over here is near -2. And this one over here is near 1. The x coordinate is near 1. So it's near this 3 number. So we know the root should be near -4, -2, and 1. Now, when we try to solve this equation, that's the same as solving this equation over here. We can just move everything to the left side and then leave the other side equal to 0. Now, we're going to use Newton's method. So that's why we want to have a function. So we're going to let the function f of x equal to this. And we're going to take the derivative of this because in Newton's method, we're going to use the derivative also. So we're going to take the derivative of this function, and that's equal to -phi sine x minus 1. Now, Newton's method says that x of n plus 1 is equal to xn minus f of xn over f prime of xn. So now we're going to start with this three approximation over here. If I start with -4, and I'm going to apply this Newton's method and use this expression to find x2, I will get this. And then iterate again, I get x3 is about this, which is about equal to x4. These two are going to agree at this 6 decimal places. So when these two they agree at 6 decimal places, and all we want is the answer here should be correct to 6 decimal places, then we can just stop. And then similarly, the second approximation for this root, right? Here is -2, and then we just go through the Newton's method, use the formula here. Again, we come up with this. x4 and x5, they agree at this 6 decimal places. So I stop. And then lastly, for this one, we're going to go through the Newton's method again. We're going to go through the Newton's method again, and then we come up with this. And then these two, x4 and x5, they agree at the 6 decimal places. So we stop. So the answer here will be this, and this. So we should have 3 of them. So those are the answers right there. Okay, I guess the difficulty for students here is sometimes they didn't realize that this one here says that find all root of the equation. As you can see from the graph we draw over here, there are 3 intersecting points. So there are 3 solutions. We need to find all of them.